Multiplication of matrices, scalar multiplication. As far as scalar multiplication is concerned, we have two cases, or let me just say two variables here. The first one is the scalar itself, and the second one is the constant. The constant is what actually represents the matrix, while scalar is just any magnitude you are using to multiply the matrix itself. So in scalar multiplication, suppose we have a to be equals to, that's a11, right? a12, a21, and a22, exactly. So suppose we have matrix A to be equals to this, and let's say we have our k to be the scalar, exactly. So now what will happen in scalar multiplication is that we are going to have something that will be in form of, that's k a, exactly, where our k is the scalar and our a is the matrix itself. That's as far as scalar multiplication is concerned. And scalar multiplication is also known as scalar product of matrix. So whenever you have matrix A and constant k, whenever you have matrix A and constant k represents the scalar, while matrix A represents the constant itself. You understand what I'm saying now? So in this case now, simply we multiply k by x is going to give us, that's k multiplied by our a, which is a11, right? a12, a21, and a22. So what you actually need to know basically under scalar multiplication is that as far as scalar multiplication is concerned, we are going to have what we call the constant and also the scalar. The scalar is the k, right, which represents the magnitude, any magnitude you are using to multiply the constant, which is the matrix, which is the body. So now suppose we are given x to be equal 4, right? Okay, minus 11, you are having minus 8 and 3, and you are given y to be equal minus 5, 1, 0, and 6. So you are now asked to find that's a 2y, b you are asked to find minus 3y, and c you are asked to find 4x minus 2y. So how can you differentiate between matrix multiplication itself and scalar multiplication itself? Scalar multiplication will involve a constant and scalar. In this case now, we are asked to find 2y. In this case, these two represent our scalar, while our y represents the matrix. So now let's go ahead and find 2y. So in this case now, we are having 2 multiplied by what? Multiplied by y, which is minus 5, 1, 0, and 6. Then the answer to a is going to be something like this. That's minus 10, right? 2 multiplied by 1, that's 2. 2 multiplied by 0 is 0. Then here we are having 12. So this actually the scalar multiplication. So what this implies is that whenever you have what can I just call it? Whenever you have a magnitude multiplying anything like this, right? Multiplying everything that is inside here, it shows that you are going to use the magnitude to multiply all the elements that are present in the matrix. So let's go ahead and find 2x, right? Let's say we are asked to find 2x. Is it same thing as multiplying 2 multiplied by what? Our x, which is 4, minus 11, minus 8, and 3. So what will happen is that we are going to use our 2 to multiply all the x. 2 times 4, 8. This will give us minus 22. This one is what? Minus 16, and we have 6. Right? So that's just it, exactly. So that's it. Then let's go ahead and find minus 3y. We are given minus 3y. So one thing that you guys don't need to be confused with is that minus is actually a magnitude, right? Minus represents a magnitude. Then we are having minus 3 altogether. It represents a magnitude multiplying a constant y. So let's go ahead and do this. Here we're going to have to be minus 3. Then our y is minus 5. We're having 1, 0, 6, right? So what happens here is that we are going to use this minus 3, which represents our magnitude, to multiply all the elements that are present in the matrix. So here we are going to have the answer to be positive 15, right? Then negative 3, we are going to have this to be 0, right? Then minus 10. So that's just the answer to this, right? So let's go ahead and find the last one, which is the C, which is 4x minus 2y. So finding 4x minus 2y, let's see what's going to give us. 4x minus 2y, we need to do it one by one because we actually have different things here. It's actually a different case. So we go with the 4x first. 4x, then we are going to have it to be this. What's our x? Our x is going to be 4 minus 11, we have minus 8 and 3, right? Then minus 2y, which is our 2y. Don't forget this actually, that's something here, which is minus 10, 2, and 0, 12, right? So I'm going to put it here directly. I'm going to be minus 10, 2, 0, and 12. So let's go ahead and do this. Let's use this magnitude to multiply each element that are present in the matrix, right? So here we'll be having 4 multiplied by 6, multiplied by 4, that's actually 16, right? 4 multiplied by 11 minus 11, that's minus 44. So 4 multiplied by minus 8, that's minus 32. So 4 multiplied by 3 is actually 12, right? So that's just it. Then go ahead and subtract it from minus 10, 0, 2, and 12. This is actually arithmetic operation because it involves minus, right? This is actually an arithmetic operation. And if you have not watched my video on addition and subtraction of matrices, can you pause the video right now and go and watch it? Or better still, I will drop the link in the comments below or in the description box below. So let's go ahead and do this. Here we are going to have it to be 16 minus into bracket minus 10. That should give me what? Positive 26, right? Minus 44 minus 2. That should give me minus 46, right? Then here minus 32 minus 0 should give me minus 32 itself again. Then 12 minus 12, that's actually 0. So this is the answer for 4x minus 2y. That's it. Then let's now move to matrix multiplication itself. So talking about matrix multiplication itself is another different case entirely, right? Is a different case entirely. Let's say we have matrix multiplication here. Matrix multiplication. So what happens here is that in matrix multiplication, we are multiplying two constants together. That means two matrices together to generate a new matrices. And don't forget that whenever we are asked to perform any arithmetic operation on matrices, both the matrices x, or let me just say x and y exactly, or both the matrices must be in the same order. That is, they must have the same orientation. What I mean by orientation is that they must have the same row and also the same column. So let's go ahead and say, suppose we have matrix A to be A11, right? A12, A21, and A22, right? So, and we have matrix B to be B11, then we have here to be B12, B21, and B22, right? So suppose we have this and we are asked to find the matrix multiplication. Matrix multiplication simply means the product of these two matrices, which you can represent as 8.b, or you call it AB. But whenever you have A cross B represents the vector multiplication of matrices. So A.B represents the magnitude, or you simply say, represent the scalar, actually, as far as vector and scalar quantity is concerned. But here we are dealing with matrix. So A.B represents what? The matrix multiplication, and AB or represents as AB. Now let's go. Multiplying these two together, we are going to have something we call C. And our C is going to be C11, C12, then C21, and C22. That means we need to find our C11, C12, C21, and C22. Suppose you are asked to calculate to find, let's suppose you are given matrix A. You are given that matrix A equals to, you are having it to be 3, 4, 5, right? Then you are having this to be 2, 1, and minus 1, right? And you are giving matrix B. You are giving matrix B to be equal. You have 4, 3, minus 2, and also 5, 1, 4. Now, what it means is that are they of the same order? No, we are having everything here given as what? As 3, 4, 5, right? And you're having everything here given by what? Let me just say you are having 2 row here, right? 4 and 5. And you're having 3 column here, right? So what happens is that can this actually work out if we are asked to find AB? Can it work out? Yes, it will actually work out. What we are going to do is just that we are going to pick everything here, multiply by everything here, this multiply by this, then this multiply by this, and we are done. So now let's go ahead and multiply the two together. In short way that our AB will equals to what? Be equals to that's 3 multiplied by 4, right? 3 times 4, right? Then plus again 2 times 5. That's the first case that we're going to have. Then going with this again, going with this side, we use this word to multiply this, right? Then take this again, multiply this again. 3 times 9 will give us 3 times 3 will give us what? That's 9, right? This by this will give us 9, right? Then 2 plus 2 multiplied by 1, that's actually 2, exactly. That multiply, then pick this again and this, that's 3 multiplied by minus 2, that's what? That's a minus 6, right? Then 2 multiplied by 4, that's plus what? Plus 8, right? Then we come back to the second row here. 4 multiplied by 4 is actually 16, right? So then 1 multiplied by 5, that's plus what? 5. Then move again. 4 multiplied by 3 will give us 12. Then 1 multiplied by 1, that's plus what? 1. 4 multiplied by minus 2 will give us minus 8, right? Then 1 multiplied by 4 give us plus 4, right? So in this case now, 5 multiplied by 4 again, we have 20 plus, then minus 1 multiplied by 5 give us minus 5, right? Let's put this in bracket. So 5 multiplied by 3 will give us 15, right? Then we are going to have minus 1 multiplied by 1 plus minus 1, right? So here we have to 5 multiplied by minus 2, that's actually minus 10, plus minus 1 multiplied by this will give us what? That's minus 4, right? So let's go ahead and simplify. Simplifying this, we are going to have our AB to be 3 times 4 will give us 12, right? Plus this will give us 22, right? So this will give us 11, and this will give us 2. We are going to have this to be 21, right? We have this to be 13. We have this to be what? That's minus 4. We have this to be, that's 15 exactly. This should give us 15. This will give us what? That's 14. And this is actually minus 14. So this is also the answer. We are going to have AB to be equals to this. Now let's say, suppose we are given another question. We are given question A. We are given question A. We are suppose matrix A rather is 2, 3, 1, and minus 4, right? Suppose matrix A is this, right? Then matrix B is equal. We are having that's a 5 minus 1 minus 2 and 3, right? Suppose we are given this and this, and we are asked to find that's a BA, and we are asked to find AB. Let's see if this is actually the same. We are asked to find BA and AB.